This is one of my favorite triple integral type of questions, the tetrahedron question. So integrals for a generic function f of x, y, z. So we're not going to worry about actually evaluating the integral. We're just going to set it up because that's by far the most challenging, non-straightforward part of the problem. But once we have the iterated triple integrals, it's a breeze to breeze in the sense of that it's very mechanical. It's a little bit tedious, but mechanical. Okay, so integrals for f of x, y, z over the tetrahedron bounded by the x, y, z axes and the plane 2x plus 3y plus 5z is equal to 30. Okay, so before we do anything else, let's draw a picture for what's going on here. So we have x, y, and z, and there's going to be a plane here. So here is a cross-section of the plane. And so when I say this tetrahedron, the tetrahedron has 4 vertices. One is, of course, the origin at 0, 0, 0. And the other 3 are where the plane 2x plus 3y plus 5z is equal to 30, where that plane intersects the x, y, and the z axes. Okay, so before we do anything else, let's figure out where does this plane intercept the axes here. So for example, to find where we intersect the x-axis here, the x-axis is when y and z are both 0. So this is 2x plus 3 times 0 plus 5 times 0 is equal to 30. So that's 2x is equal to 30, x is equal to 15. So this is the point 15, 0, 0. For the y-axis intercept, this is when x and z are both 0. So 2 times 0 plus 3 times y plus 5 times 0 is equal to 30. So this is the point x and z are both 0, y we can tell there is 10. And then finally for where does this intersect the z-axis, so this is when x and y are both 0, 2 times 0 plus 3 times 0 plus 5 times z is equal to 30, z is equal to 6, so this is the point 0, 0, 6. So we're looking for the region, the tetrahedron with 4 vertices, 0, 0, 0, 15, 0, 0, 0, 10, 0, 0, 0, 6. So something that I want to point out before we actually do this is I wrote set up integrals. I was very vague about this. And in particular, I did not tell you which order to write your integrals down in. And as it turns out, we can actually do this. We can do this in any order. So we can integrate with integrate with respect to x, y, and z in any permutation of x, y, and z. How many permutations of 3 letters are there? 3 factorial 6. So there are 6 different possible answers that we could come up with here. And I've written down all 6 possible answers here. So we could go integrate with respect to z first, then y, then x, or z, then x, then y. I mean, you can read all of the possibilities here. Check for yourself that this is all possible permutations of dx, dy, dz. And then, of course, I didn't label the integrals here, integral signs here, but these would have to go in reverse order. So like this one would be x, then y, then z. This one would be y, then x, then z. So there's 6 different answers we could come up with. I don't think in this video I'm going to do all 6, but I'll do a couple of them, enough to get the flavor for what's going on. Okay, so let's start off with dz, dy, dx. So we integrate with respect to z first, and then with respect to y, and then with respect to x. And so we should know that the z bounds potentially depend on y and x. The y bounds potentially depend on x, but can't depend on z. And the x bounds must be constant. The outside bounds always have to be constant. Inside, z can depend on x and y. Y can depend on x, but not on z. Okay, so from this picture here, let's figure out what's going on. So, you know what? Let me just let me just redraw the picture because I'm going to be, marking it up quite a bit. So, okay, so x, y, z. So, and I guess I should mark 15 and 10 and 6. First things, what are the allowable x values? So, the allowable x values here run from 0 to 15. Our outside bounds must always be constant. X runs from 0 to 15. What are the values of y that we are allowed to have? Well, let's think about the projection of this. Think about the projection of this tetrahedron in the xy plane. Think about the projection of this in the xy plane. So it's going to look like a triangle. It's going to be this triangle here in the xy plane. I'm just going to redraw it in 2D instead of redrawing it instead of having it in 3D to make it a little bit easier to understand. So 15 and 10 here. So for fixed value of x, and once again we can see here x runs from 0 to 15. For fixed value x, what can we tell about y? Y runs from 0 up to this curve. 0 up to this straight line. So we need to figure out an equation y in terms of x for this line here. We can do this y is equal to mx plus b form. So the intercept here is 10. And the slope here is going to be negative, negative 2/3. It's going to be when we go from this point to this point, y goes down by 10, x goes up by 15, so it's negative 10 over 15, which becomes negative 2/3 x. So this fills in our bounds on y. So y can run from negative 2/3 x. The lower bound was y is equal to 0. The upper bound is negative 2/3 x plus 10. By the way, before I do the z bounds, let me point out a different way to come up with y is equal to negative 2/3 x plus 10, and that comes from this equation right here. So we start with 2x plus 3y plus 5z is equal to 30. So that's the equation of this plane. We are looking for an equation of this line here, which is the intersection of this plane with z is equal to 0. And so we have 2x plus 3y is equal to 30. Solve for y in terms of x. 3y is equal to negative 2x plus 30 divided by 3, negative 2/3 x plus 10. That's another way to come up with y is equal to negative 2/3 x plus 10. Okay, so the last thing we have to do here is that we need to fill in z in terms of x and y, what are bounds on z in terms of x and y. So for a particular point in the xy plane, z runs from, it looks like z is running from 0. The smallest z can be is 0. And we go up until we hit the plane we hit the plane. Of course, the equation for the plane is 2x plus 3y plus 5z is equal to 30. And now we want to write z in this plane in terms of x and y. So how do we do that? 5z is equal to negative 2x minus 3y plus 30. Divide by 5. Z is negative 2/5 x minus 3/5 y plus 30 divided by 5 is 6. So here is our upper bound on z, negative 2/5 x minus 3/5 y plus 6. So this is our final answer to the first part here. Z runs from 0 to negative 2/5 x, negative 3/5 y plus 6. Y runs from 0 to negative 2/3 x plus 10. X runs from 0 to 15. Again, let me emphasize, our outside bounds are constant. These must be constant. Y bounds are allowed to depend on x, but cannot depend on z. Z bounds can depend on x and y. Okay, so that was one order here. There's 5 more possible orders. Let me do 1 or 2 more here. Let's go ahead and do dzdxdy. So for the dzdxdy, the change here is that we integrate with respect to y first, and then with respect to x, and then with respect to z. So, sorry, I just said that in the wrong order. Z first, then x, then y. Once again, we want z in terms of x and y. We want bounds in z in terms of x and y. For a generic point in the xy plane, again, z is still going to run from 0 to negative 2/5 x minus 3/5 y plus 6. So that doesn't change. What about y bounds here? Y bounds can be anything from 0 to 10. Y can be anything from 0 to 10. And now we want x in terms of y. So I can reuse this picture here, but now I'm slicing it horizontally, not slicing it vertically. X runs here from 0 out to this curve, out to this line here. This line is 2x plus 3y is equal to 30. Now we solve for x in terms of y instead of y in terms of x. And we end up with x is equal to negative 3/2 y plus 15. And so x running from 0 to negative 3/2 y plus 15. These are our bounds in this order here. So note once again, the outside bounds are constant. The x bounds can depend on y, but can't depend on z. Z bounds depend on both x and y. Okay, let's mix up a little bit. Let us do this order down here, dx, dz, dy. So once again, I need to draw tetrahedron, 15, 10, and 6 here. So dx, dz, dy, we integrate with respect to x first, and then with respect to z, then with respect to y. So our outermost bounds on y, we should be able to tell just from this that y bounds are going to run from 0 to 10, just like they did up here. Now we need z bounds in terms of y. And to do this, what we're going to do is now we need to look at that triangle right there. We need to look at the projection of the tetrahedron into the YZ plane. So 10 and 6. And so once again, we see here the projection of this into the YZ plane is this right here. How to come up with Z in terms of Y. The smallest Z can be is 0 for a fixed value of Y. The largest Z can be is this curve right here. And once again, okay, so 2x plus 3y plus 5z is equal to 30. In the YZ plane, this is when x is equal to 0. So that becomes 0. 3y plus 5z is equal to 30. We solve for z in terms of y, and we end up with negative 3/5 y plus 6. And so this gives us here z runs from 0 to negative 3/5 y plus 6. Okay. And then finally, what are our bounds on x? For a fixed point in the in the YZ plane. So x can be 0. It starts at 0. And it runs until we hit the plane here, the plane with equation 2x plus 3y plus 5z is equal to 30. Solving for x in terms of y and z, x is equal to negative 3/2 y minus 5/2 z plus 15. So there's our upper bound there. Negative 3/2 y minus 5/2 z plus 15. Okay, so I did 3 of the possible orders here. This one would be dx, dy, dz, so do the same picture, but now slice it, integrating with respect to setting up y bound in terms of z there. But then the x bounds would stay the same. For these two, so the last two variables here are z and x in some order. So for those, note that we project here into the yz plane. We project here into the xy plane. And so for these two, we would be projecting into the xz plane. And it goes through in much the same way. This video is close to 18 minutes long, and it's time to call us wraps here. But I think this is a very useful problem. Here's a pre-class problem for you to try, write down, but don't evaluate. Iterate integral for the function f of x, y, z is equal to x plus z over the region. X, y, and z are all non-negative under this plane. You should find out that, again, this is going to be a tetrahedron. I'll let you work through this. You pick the order. Try as many as you want to.